wire encountered is most likely type USR, which stands for Underground Service Entrance Rubber. Let's examine its characteristics. Firstly, the conductor is copper. Secondly, the insulation consists of a rubber layer. Thirdly, the covering is a black or brown fabric layer. The towel-like substance described is likely a moisture-resistant coating. Type USR wire is primarily used for underground service entrance connections to buildings. It can also be used in wet or damp locations where direct burial or exposure to moisture is expected. Determining the ampacity of type USR wire depends on the size of the conductor and the temperature rating of the insulation. Without specific markings on the wire, determining its exact ampacity is difficult. However, based on the assumption that it is number 6 American wire gauge wire, the approximate ampacities for different temperature ratings are as follows. At 75 degrees Celsius, which is 167 degrees Fahrenheit, the ampacity is approximately 60 amps. At 90 degrees Celsius, which is 194 degrees Fahrenheit, the ampacity is approximately 75 amps. At 105 degrees Celsius, which is 221 degrees Fahrenheit, the ampacity is approximately 90 amps. These are approximate values and may vary slightly depending on the specific manufacturer and wire configuration. It's always recommended to consult the manufacturer's specifications or a qualified electrician for accurate ampacity information. It's crucial to remember that working with electrical systems can be dangerous. If there's uncertainty about the type of wire or its ampacity, consulting a qualified electrician is essential. They can accurately identify the wire, determine its safe ampacity, and ensure that any electrical work is performed in accordance with safety codes and regulations. This is particularly important in older buildings where wiring may not meet current standards. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always prioritize safety and consult with the qualified experts when dealing with electrical systems. In addition to the temperature ratings mentioned earlier, it's also crucial to consider the ambient temperature in which the wire is installed. Higher ambient temperatures can reduce the ampacity of a wire, as the insulation may not be able to dissipate heat as effectively. The National Electrical Code, or NEC, provides guidelines for dating wire ampacity based on ambient temperature. It's essential to consult the appropriate NEC tables to determine the correct ampacity dating factor for the specific installation conditions. Furthermore, the type of enclosure or conduit in which the wire is installed can also affect its ampacity. Wires installed in enclosed spaces, such as conduits or raceways, may have a lower ampacity than wires installed in open air. This is because the enclosed space can restrict heat dissipation, leading to higher conductor temperatures. The NEC provides guidelines for adjusting wire ampacity based on the number of conductors in a raceway or cable. It's important to consult these guidelines to ensure that the wire is not overloaded. When working with older wiring, it's also crucial to inspect the insulation for signs of damage or deterioration. Over time, the insulation can become brittle, cracked, or worn, which can increase the risk of electrical shock or fire. If the insulation is damaged, the wire should be replaced with a new wire that meets current safety standards. In addition to type USR wire, there are several other types of older wiring that may be encountered in older buildings. Some common types include knob and tube wiring, which consists of single insulated conductors supported by ceramic knobs and tubes, and non-metallic sheathed cable, also known as Wurmex, which consists of 2 or more insulated conductors enclosed in a non-metallic sheath. Each type of wiring has its own unique characteristics and ampacity ratings. It's important to be able to identify the different types of wiring and understand their limitations. When replacing older wiring, it's generally recommended to use modern wiring methods that meet current safety standards. Modern wiring methods, such as non-metallic sheath cable with a ground wire, provide better protection against electrical shock and fire. It's also important to ensure that the new wiring is properly sized for the intended load. Overloading a circuit can cause the wires to overheat, which can lead to a fire. In addition to replacing the wiring, It's also important to upgrade the electrical panel to ensure that it can handle the increased load of modern appliances and equipment. An outdated electrical panel may not have enough capacity to safely power all of the electrical devices in a building. It's also important to install ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electrical shock, such as bathrooms and kitchens. GFCIs are designed to detect small electrical leaks and quickly shut off the power to prevent electrical shock. In summary, identifying older wiring types like type USR is crucial for ensuring electrical safety. Understanding their characteristics, ampacity, and potential limitations is essential for making informed decisions about electrical repairs and upgrades. Always consult with a qualified electrician to ensure that all electrical work is performed safely and in accordance with applicable codes and regulations. Remember to consider factors such as ambient temperature, enclosure type, and insulation condition when determining the appropriate ampacity for a wire. Upgrading older wiring to modern methods and installing safety devices like GFCIs can significantly improve the safety and reliability of an electrical system. The information provided here is for educational purposes only and should not be considered a substitute for professional electrical advice. Always prioritize safety and consult with a qualified expert when dealing with electrical systems. In addition to the points already discussed, it's important to emphasize the significance of proper grounding in electrical systems, particularly when dealing with older wiring. Grounding provides a low resistance path for fault currents to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock. In older buildings, the grounding system may be inadequate or even non-existent. It's crucial to ensure that the grounding system is properly installed and maintained to provide adequate protection. One common issue in older buildings is the use of metal water pipes as the primary grounding electrode. While this may have been acceptable in the past, it's no longer considered a reliable grounding method due to the increasing use of plastic pipes in water systems. Plastic pipes are non-conductive and cannot provide a path for fault currents to flow. It's important to supplement the metal water pipe with an additional grounding electrode, such as a ground rod or ground plate, to ensure that the grounding system is effective. The NEC specifies the requirements for grounding electrodes and grounding conductors. It's essential to consult the NEC to ensure that the grounding system meets these requirements. In addition to grounding, bonding is another important aspect of electrical safety. Bonding involves connecting all of the metal parts of an electrical system together to create a low impedance path for fault currents. This helps to equalize the voltage potential between different metal parts and reduce the risk of electrical shock. Bonding is particularly important in areas where there is a risk of electrical shock, such as bathrooms and kitchens. All metal enclosures, such as electrical panels, junction boxes, and appliance housings, should be properly bonded to the grounding system. The NEC specifies the requirements for bonding conductors and bonding methods. It's essential to consult the NEC to ensure that the bonding system meets these requirements. When working with older wiring, it's also important to be aware of the potential for asbestos exposure. Asbestos was commonly used as insulation in older buildings, including electrical wiring. Asbestos fibers can be released into the air when the insulation is disturbed, which can pose a health risk if inhaled. If asbestos is suspected, it's important to take precautions to prevent exposure. This may involve wearing protective clothing, using a respirator, and wetting down the asbestos-containing material before disturbing it. It's also important to dispose of asbestos-containing materials properly in accordance with local regulations. In some cases, it may be necessary to hire a qualified asbestos abatement contractor to remove the asbestos-containing material safely. Another potential hazard when working with older wiring is the presence of lead-based paint. Lead-based paint was commonly used in older buildings, including on electrical components such as junction boxes and conduit. Lead is a toxic metal that can cause health problems if ingested or inhaled. If lead-based paint is suspected, it's important to take precautions to prevent exposure. This may involve wearing protective clothing, using a respirator, and wetting down the paint before disturbing it. It's also important to dispose of lead-containing materials properly in accordance with local regulations. In some cases, it may be necessary to hire a qualified lead abatement contractor to remove the lead-based paint safely. In addition to the technical aspects of working with older wiring, it's also important to consider the legal and regulatory requirements. Electrical work is typically regulated by local codes and ordinances. It's essential to obtain the necessary permits and inspections before performing any electrical work. Failure to comply with these requirements can result in fines or other penalties. It's also important to be aware of any historical preservation regulations that may apply to older buildings. These regulations may restrict the types of electrical work that can be performed or require the use of specific materials or methods. It's essential to consult with the local building department to determine the applicable requirements. Finally, it's important to document all electrical work that is performed. This includes creating a wiring diagram, labeling circuits, and keeping records of all inspections and permits. Proper documentation can be helpful for future maintenance and repairs. It can also be useful if the building is ever sold or renovated. In conclusion, working with older wiring requires a thorough understanding of electrical principles, safety practices, and regulatory requirements. It's essential to be aware of the potential hazards and take precautions to prevent accidents. Always consult with a qualified electrician to ensure that all electrical work is performed safely and in accordance with applicable codes and regulations. The information provided here is for educational purposes only and should not be considered a substitute for professional electrical advice. Always prioritize safety and consult with a qualified expert when dealing with electrical systems. Remember that electricity is a powerful force and it should be treated with respect. By following proper safety procedures and consulting with qualified professionals, you can ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations.